Hi.
Hi, my name is David Steele from Arcturus. We've been working with 42T to develop this line inspection demo. And I'm going to talk a little bit about the software that's running on it. So first of all, let's talk about hardware. We're running on the Synaptics SL1680. And what we're doing is we're running a model that is doing object detection to detect pills. And then we're doing color sampling of those pills to identify the specific color they are so that we can identify contaminants, like the wrong sort of pill in the spot at a different time. And also we're doing algorithmic method of identifying anomalies, such as the incorrect object on the conveyor at any time. One of the cool things that we've done with this is really worked pretty hard to optimize it for the Synaptics hardware as well. So with this model, it's a YOLOv8 model that we're using for object detection. We're actually optimizing it by using the pre-processing for the model on the NPU as well, which actually saves us a lot of CPU resource, which helps us use that CPU for our visualization and presentation as well.
So how much is out there in the world that can be optimized for NPUs, or do you need to do all the optimization yourself to make it amazing?
Yeah, so that's a great question. So this model was built from scratch. It's a YOLOv8 model, but we trained it on a data set that we built. And then what we used was the Synaptics toolkit. So Synaptics provides a tool that allows you to do the model conversion to optimize it for the NPU. And as a function of that, we can actually build in the pre-processing. We can specify the pre-processing that's required in the YAML file of that model. And then when we export it, it effectively adds that pre-processing code in, and that's what gives us a huge performance uplift.
So how difficult is it to create devices in the future that have all this amazing kind of, what do you call this kind of model?
So the detection model is running on here as a YOLOv8 model. What we're seeing in this visualization is our software stack. So it's a kind of a full stack system that includes all of the events and the visualization, and it gives you all the notifications and the counting, and produces all of the outcomes you're trying to get out of an ML system. In this case, a line inspection and clearance demo.
And it's got a great low latency, lag, and everything. It needs to be implemented.
That's right. It's all in real time. So, obviously you don't want any delays in your line inspection. You want to be able to count your pills pretty accurately and pretty quickly. So it's very low latency. That's part of that optimization process that we go through. So trying to create parallelization as best as we can by using the different specialized compute units.
So how much fun are you having in the company with all this AI stuff that's happening?
So that's probably that's the greatest question I've ever been asked. With the speed that innovation is happening in AI, you kind of turn around and you find something new. What's really exciting for us is the advent of VLMs and how they're just kind of proliferating to come up with really interesting new use cases at the edge. And quite frankly, we're just starting to understand how to take advantage of that, and that makes us really excited.
Because when I chat with the ChatGPT or the Grok or something, it's something else to have something that counts the pills and checks for the anomalies and everything. What's the difference?
I think what you're asking is, how can we add natural language to this to actually get it to prompt for better information and better, more human understandable outcomes? Is there a correlation for the type of anomalies that we're getting, or can you tell me how many pills that have failed in the last little while? And doing that sort of stuff is, just adding another model to the whole ensemble that we're running, which is completely achievable.
How hard or how easy is it to integrate new models in demos?
Well, that's a good question. So upgrading a model from the same type is relatively straightforward to do. So we can train a new model, update it, and deploy it very easily. In fact, we offer some tools to help do that. We offer something called MLOps, which can be run right in the edge. And what that actually does is it actually gathers data from the device that's running. It builds a new data set, it then trains a new model, and then compares the performance of that model with the model that's currently running, and then can update that model in real time. So, and we can do that all at the edge as well. So that's a life cycle of continuous model improvement.
All right. So there's a lot of interest for this demo here, right?
Definitely. So, I think industrial inspection is kind of rife for taking over, for AI to take over. there's a lot of applications out there today that are using kind of legacy algorithms or very basic sort of inspection systems. AI can really enhance that analysis significantly. And it can do it fairly cost effectively too, because we can run fairly low cost by CPU and system cost models to get pretty amazing results on inspection.
How many AI projects do you have at the company?
Well, we probably got about 6 on deck right now, so which is about all we can take on. Without sort of burning ourselves out. So, and this is one of them we've just been working on completing. We did this one in about 4 weeks.
Oh,
so.
I cut before you said that.
That's fine.
Ah, cool.
Yeah.
Cool. Thanks a lot.
Thanks. Did I answer your questions okay?
Yeah, it was great.
Okay, good. Okay.
Thanks a lot.
Cool. Do you want your mic back?